Hey there, Physical Science. This is Ms. Ruark. This is podcast 4.3, where we're going to talk about magnets and how magnets work and energy transfer. All right, so magnets. Magnets are things that contain magnetic poles. So far we've been talking about positive and negative charges. Well, when we're talking about magnets, we're talking about north and south poles. You can think of them as something that's going to be similar to charges with positive and negative. Okay, now the thing about poles is that they're impossible to isolate. We can actually isolate positive and negative charges, but we can't isolate positive and negative poles because here's a magnet. Notice how the north pole is on this side and the south pole is on this side. Well, if we split this magnet in half, what would happen is, because this is south, this would become a north pole, and this would become a south pole. So it's absolutely impossible to isolate them. Well, they do behave like charges. Okay, when we say they behave as if they're charges, like charges repel, so like poles will repel. Opposite charges or opposite poles will attract, which means that if you put two north poles by each other, they're going to repel. If you put two south poles near each other, they're going to repel. If you put a north and a south near each other, they're going to attract. Okay, same thing with their force, the magnetic force. If you move them closer to each other, you're going to increase that magnetic force. And if you move them further apart, you're going to decrease the magnetic force. Okay, and the magnetic force, remember, is just the pull. It's the attraction and repulsion of those poles. Okay, a permanent magnet. You can actually make something into a permanent magnet by taking it and you can take it and stroke it or rub it several times with a magnet. So if we had a piece of iron and we took a magnet and rubbed it up and down on the piece of iron, we could actually turn it into a magnet. Now, it's called a permanent magnet. The force, though, however, can be weakened or removed, and it can be weakened or removed by hammering it or by heating it. So if you take that magnet that we've just induced and we heat it or we hammer it, we would actually be able to weaken the force or remove that force altogether. All right, magnets will exert forces on each other. So what does that mean? Well, let's say we take that magnet there and we put it into a bucket of nails. The magnet will pick up several nails. It won't just pick up the ones that are directly in contact with it. It'll also pick up these stray ones here. Like this one's not touching the magnet. This one's not touching the magnet. This one's not. Okay, there's a bunch of them here that aren't directly touching the magnet. Well, how's the magnet picking it up? Well, the magnet will touch the nail, and it exerts a force, a magnetic force, on that nail. Okay, well, that magnetic force in that nail has now made that nail a magnet temporarily. The magnetized nail will exert a magnetic force on the next nail, and so on and so on. Okay, now you're not going to be able to have an unlimited number of magnets or nails coming off of this. Eventually, the chain will stop. Like all the number of magnets that come dangling off of this will stop. And it can be stopped by a couple of different things. It can be stopped by the strength of the magnet. If the magnet is not strong enough, then the chain will not be long. And it also depends on the ability of the object to be magnetized. If the object is something that doesn't prefer to be magnetized, it'll only be able to pick up a small amount. If it prefers to be magnetized or it gets magnetized easily, it'll pick up more. And I'll show you what I mean in class when I show you my Einstein head and my paper clips. All right, magnetic fields. So just like when we had electric currents, we had electric fields. Well, guess what? With magnets, we have magnetic fields. Okay, a magnetic field is an area where a magnetic force is detected. Okay, and how is it created? It's created by moving particles. And the field lines that are produced are always going to produce closed loops. Okay, closed loops. So what does that mean? Well, here's a north end of a magnet and a south end of a magnet, and a bunch of iron pieces around it. Okay, if you'll notice, these are closed loops that it's forming. They are going from one magnet to the other, and it looks like it's directly in contact from one to the other. Well, when you get out here, there's not much here, but guess what? They come around like this. Okay, they're coming around like this, and they're constantly looping. It's going to be constant looping, right? And it's always going to be closed because it goes from one magnet to the next. Okay, an example of it is over here. It's flipping through the pictures, but here you see how this is a closed magnet. Don't worry about this picture. But the other one is a closed magnet where it is looping. Okay, so that's a closed magnet. Okay, always produces those loops. And what direction does it go? Well, it goes from positive to negative in electric currents. Guess what? It goes from north to south in a magnet. All right, a compass. Some of you may be familiar with a compass. A compass is something you use to find your way when you're hiking or you're lost, right? Your car, if your car tells you northwest, north, all those, it has a compass in it most likely, right? And the compass is what tells us what direction we're going. Well, the compass is aligned with the Earth's magnetic field. Okay, magnetic field. Okay, the compass is always going to point towards geographic north. Geographic north. Okay, when you're reading a compass, you'll hold the compass and the compass will always point north to show you which direction the north is. That way you can figure your way around. Well, guess what? The geographic North Pole is not the same thing as the magnetic North Pole. They are not even close, actually. The geographic North Pole is the same thing as the magnetic South Pole. Yeah. It's crazy, isn't it? And the geographic South Pole is the same thing as the magnetic North Pole. Okay, so there are opposites. Just remember that. Okay, if we wanted to increase the strength of a magnet, we can create what we call an electromagnet. Now, way you can create an electromagnet is if you take a magnet or something that is magnetized and wrap it in wire. And if that wire is connected to a voltage source, you would create what we call an electromagnet or a solenoid. Okay, solenoid. So this is an example of one. Right here we have this nail. It's wrapped in this copper wire or some type of wire, okay, and it's connected to a voltage source, which would be this battery here. Okay, and that's what it would create a stronger magnet here on the nail. Okay, here's another example of one that's not a drawing, but it's an actual a little bit more. And there's a switch here. You guys know what that is. It turns the power on and off. It either opens the circuit or closes the circuit. If it opens the circuit, no current flows. If it closes the circuit, the current is allowed to flow. And see how many pens it's picking up here because it is magnetized even more. All right, if we want to increase the strength of that, if we add more coils, we will make it more... I don't know what I was trying to put here. I want to say stronger, but more strong. There we go. More coils equals more strong. All right. Okay, generators and motors. So let's talk about generators and motors since we were just talking about solenoids and electromagnets. Okay, a generator and a motor, you might think, oh my gosh, they do the same thing, right? Well, a generator is going to be something that you would use for your house, or if you're camping and you want to turn on lights or you want to work a stove or, what have you. If an ice storm comes through, a lot of people go out and buy a generator so they can power their house and make their coffee and keep their food cold and et cetera, run their heat. Okay, so a generator is actually going to take and convert mechanical energy. Okay, mechanical energy is the energy of movement. It's the machine working itself. It converts it into electrical energy. Okay, and electrical energy is what you use to power your house. Well, guess what? This motor is something that you would see inside of a car. Okay, or, well, this wouldn't be inside of a car, but, car, okay, because that wouldn't be the one inside of a car. You guys know what a motor inside of a car looks like. This would be something that's more inside of like a smaller appliance, but a motor is going to take that electrical energy and it's going to convert it into mechanical energy so that things will be able to move and power. Okay, so a generator is mechanical to electrical, a motor is electrical to mechanical. They do the exact opposite. Okay, and then the last thing we need to talk about is when we transport that energy. When we transport energy, you can't just take it straight from the power station and straight to your house because the power station is going to produce a lot of energy and your house will explode because it's so much energy. You can't do that. So we have to use these things called transformers. I don't know, you're thinking, ooh, Bumblebee, right? No. A transformer, before the invention of the transformers, more than meets the eye, Grand Optimus Prime and all that, right? But we're not talking about those. We're talking about transformers that are used to step up and step down power. So a step-up transformer is used to increase power, And they do that when it leaves the power plant. So here's the power plant, and the energy goes into um, the step-up transformer. Here's an example of something that you would see as step-up or step-down transformer. Okay, it would step up the energy because those electrical wires, those power lines, are able to conduct an extreme amount of energy, so it's just spitting that energy out. It's letting it go. Well, guess what? When that energy gets to your house, you don't want it to blow your house up. So we've got to step it down. We're going to step down to decrease the power so that it doesn't blow anything up, right? It makes it so that it's manageable bits that go into your house and you can actually power all your appliances. Okay, and I think that's about it, ladies and gentlemen. Hopefully that makes more sense about magnets, and I'll see you in class.